Okay, so our topic for today is all about open loop control system. Okay, so for this, my example is we are going to visit the house and see if we can find something on the kitchen. So one of the devices you use daily in your kitchen is a toaster. So normally how you apply this is you put the bread on the toaster. So when it's done, it will pop out. So this is one basic example of a control system. So it's an open loop control system. It takes an input, time, and then gives an output, which is the bread color. So it depends on the heat, how intense is the bread color. So it depends on you what is your desired bread color. So in this case, you can do a couple of experiments until you meet the desired bread color. So there will be different input and wait until you meet your desired input. So in this case, so if we are going to graph the the control system for a toaster, so we can use the bread color as your Y. So you're familiar with your um, Cartesian plane. So we normally have this as the Y axis, and then this Y is the X axis. So the bread color is on Y, and the timer level is on the X axis. So timer level depends on the toaster that you are making. So in this case, on my example, we are using 2, 4, 6. So this is a sequence. As you can see, it's by twos. So it's 2n if you're going to use this for a sequence. So 2n. So if you're familiar with mathematics in the modern world, you are going to get the value of the next sequence here if you multiply your natural number by 2. That's why it's a sub n is equals to 2 multiplied by n natural number. So that depends on you. That's on my example. So you can use any other method for that. So in this case, our start, we will set the timer to a level of 2. So it's just a simple thing that we can do on the graph if we do it manually. But if you're using a simulation tool, same as what I have indicated on my laboratory activities, they normally generate the graph automatically. So they will just need to input there the intervals and the graph will be automatic. But if you are going to plot it manually, so for every time that you have the timer here like 2, 4, 6, 8, you will indicate here the color of the bread until you meet the final color that you intended on your study. Okay, so we will see later on what would be the color of the bread that I set up on my example here. So it gives you for the 2 it gives you light brown, and then for the next experiment 4 will give you medium brown, and then if your input is 6 you will get a dark brown color. So if you now fit a curve through these points, this will be your model for this control system. So this will be your steady state for your desired bread color. So if you want to find this mathematically, you just need to equate the input to U and then the output to Y to get the different values of Y here. So you can write the function Y is equals to the function of U, which is our x-axis. So in mathematical terms, as I mentioned earlier, this corresponds to your inverse function for you to be able to get the value of y. So let's jump to another example of an open loop system. So this is a warm shower. So what we are observing here is a temperature and the shower level. So in this open loop system, the handle position is the input and water temperature is our output. So to help the user, you have two different positions, and based on this, the water temperature will change. So let's go back to that part. Okay, so the handle position is our input, and then our output is the water temperature. So the handle position, if you're familiar, if you already went to hotels, there is a level there. Like you can what do you call that? You can turn the level position to different temperature there. So for example, if you go to warm, medium warm, and then hot, I'm not sure if you're familiar with it. If you turn the handle on the position, you will get a desired amount of temperature. So in this case, your handle position, since it's gonna be your um, input, it's gonna be located on your x-axis here. So you just need to put here the different levels, and then you will put here your water temperature as your output if you're going to do a graph. So let's go back to the graph earlier. So if we have this one, this will be your this would be your input, and then this will be your output. So for every turns, so for example, 1, 2, 3, 4, 5, you will have a different amount of temperature here. So it depends on your design. The ending of your control system will be indicated depending on your design temperature. So until he meets the proper temperature that you indicated on your objective, you will have a time interval here depending on the turns that you use. So it will be based on the different time level, and then it will have the temperature that you desired here. So if the temperature is still not meet on this part, there will be an error here. So you plot it here. You go to the next time. So if we have 1 minute, then we can have 2 minutes here. There will be a set of another temperature here. If it's still not meeting the temperature that you indicated, it will be an error. So you plot it here. That's why you will be able to get another graph until you meet the steady state. So the steady state, as I mentioned earlier, it's your temperature that you indicated on the objective. So for example, you indicated that on your control system, the indicated temperature for a human body to actually tolerate, and the warmest that the body can tolerate is around this degree. So it will be depending on your study. So whatever you indicate here, that will be your final temperature and that will be your steady state. So when we say steady state, that's where your control system will stop. So why it's stopping? Because we are using an open loop system. So we've discussed last meeting that for an open loop system, there's only an input, process, then output. So there's always an ending. It's not looping to anywhere. Your system will stop to the desired state that you actually dedicated depending on your system. In this case, we have earlier the toaster, and then we also have the shower handle and the temperature. So let's continue. So I have here another example. Okay, let's try to check when is a control system will fail. So let's go back to our example earlier, the toaster. So through trial and error, you will actually found the setting of the timer to 3. It will gives you a desired color. So what happens when you put a different bread? Because it's only designed for a specific bread, like a tasty bread. But what will happen if you put a different kind of bread, like a donut or a bagel? So let's see what will happen. So since it since you put a different kind of bread, it might go to burn the bread easily. Why? Because you designed only your plant is only designed for a specific type of bread. So the specific type of bread is your tasty bread. So so that means that if you put a different kind of bread here, whatever kind of bread you put here, it will give you a different output. Why? Because the texture and the shape and the size of this bread is different than this one. As you can see, it has a circle here. So meaning to say, the amount of um, yeast here is lesser than the amount of yeast on this bread. So if we are going to go back to our chemistry, if the if the texture of a certain material will change, it may actually burn easily or it may burn slowly. So depending on the texture. So the thicker um the thicker it is, the slower it burns. The thinner it is, the fastest it burns. So we are all familiar with that. So we cannot actually forget that. We are also applying not only mathematics in control system, but also we are applying the different sciences because we are observing um, natural environment here. That's why we are creating control system. It's either we control the natural environment or a physical device or a person. So as you can see, if this is gonna be a different kind of bread, you will have a different graph compared to the one that you have before. So it will have a different color here since it will be burning faster compared to the old one. So that's why we also need to indicate that. So if we are using this for our thesis or any project, it's up to you if you want to put it on the limitation or you want to study it further. So meaning to say you will have a different set of graph per bread. So you will indicate that on your system that for this bread, these are the sets of number. So you have to indicate that on your data analysis so that other researcher that will be reading your work will easily understand um, your system is for all kinds of bread, but it actually the result will depend on different kinds of bread. So in that case, it will give you more time to study further. Why? Because you would need to study the texture and how the bread is made. And you would need to study as well how fast it will burn so that the color will change. Okay. So okay. So